All right, guys. Good evening. Thank you very much for joining us tonight at our first webinar. This is in collaboration between AI Pilipinas and Flutter PH. Just to give a quick background about myself, so I'm Ralph. I'm one of the founder of AI Pilipinas, and we're happy to collaborate with Flutter PH in this meetup, along with their lead Joshua. And we're lucky also to have here a friend of mine from Nepal who would be sharing and talking about building AI applications using TF Lite and Flutter, Kshitiz Rimal. So before we begin with the actual workshop, we'll just have a run through or give a quick introduction as to our community, what it is all about. I'll be talking about AI Pilipinas, and then I'll pass the discussion about Flutter PH to Joshua, and then we'll have Kshitiz start with the workshop for tonight. So AI Pilipinas, we started like way back 2017. So our primary goal is to help Filipinos create a network of Filipinos who would want to learn artificial intelligence and machine learning, and be able to collaborate not only between developers, but also with researchers who have experience doing work in the academe and who have been doing work in the industry, so that we can actually grow in terms of skills, in terms of capabilities as a country. So right now we have around 1,400 members on our Facebook group. So if you're not part of our Facebook group yet, you can just go visit our Facebook group. And our meetup, we have around 700 plus people there. You can join our meetup if you haven't joined it yet. So for the past few years, we have been doing a lot of like workshops. We've been doing trainings in different parts of the country. So we have been doing talks about TensorFlow. We have been doing meetups every month or every other month. So this is our first meetup for this year. And we're doing it on Zoom, doing it on digital, because as we know, with what's happening across the globe. So, but again, we'll still find our way to relatively share knowledge to the community itself. So just some community guidelines. As we know, we're part of the same community, so be nice. So be friendly and generally be a nice person with all of the people here. Again, our goal is to have collaborations between individuals here, probably do some projects together or join some contests together, and figure out how we can actually work. And again, be respectful and constructive. So if you have any questions, please relay that as respectful as much as possible. So we know that we are a very diverse group. So we do recognize that we do not agree all the time, but at the same point in time, we relatively accept criticisms, and we do it respectfully. So at the same point in time, we are be collaborative, so we can actually work together and we can learn a lot from each other. This is relatively open to if your background is just if you're just really starting immersing yourself in Flutter or immersing yourself with artificial intelligence and machine learning, we're relatively open to different various backgrounds. And again, participate. This is your community, so be part of it. Join in our online discussion. So we're not just only limited to discussions here, but we also bring our learning beyond our discussion in our webinar. So again, show up in in-person meetings. We don't have any in-person meetings now, so we're just doing it online in digital. So, and we also are open to any feedbacks that you would be having for us on how to improve this further. And then if you would want to be part of the team itself, especially on AI Filipinas, don't hesitate to reach out to me. We need to we need a lot more people who can actually help us start the groundwork of helping Filipinos or helping the Philippines grow its talent and capabilities on machine learning. So that's it for AI Pilipinas. I'll be sharing the screen now. Or Joshua, are you ready to share about and talk about Flutter?
Okay, let me just share my screen. Okay, maybe you could stop sharing yours
Yep.
first. Okay, okay. I'll share mine. Okay, can you guys see my screen?
Yes, Joshua.
Okay, so yeah, so hi. First of all, I'd just like to introduce myself. I'm Joshua. I'm one of the community leads for Flutter Philippines, and yeah, I can't move this one. Okay. So Flutter Philippines is an open and collaborative community for everyone. So here we aim to help companies, developers to utilize Flutter and Dart as part of their primary tools on building awesome software applications. So across Facebook and Meetup, we have almost over 1,000 members. So we hope to, after this workshop or webinar, maybe some of you could actually join us. And yeah, these are just some of the events that we held last year and some including this year. So we held one of the very first Flutter hackathons in Southeast Asia and here in the country. We're supported by Google developers for this movement. And yeah, this is the poster. I believe some of you may have seen it on your Facebook account. So yeah, hopefully this year we'll be hosting another hackathon, and yeah, hopefully we can invite some of you to join our event after it has been posted on our account. So these are just some of the events and study jams we held last year in our office at the Gig City, Makati. We also have a study jam at Cebu in the province. And this is a picture from last year's DevFest. And this was our last on in-person meetup since due to the COVID issue, we had to move uh, all of our meetups online in a webinar format. So yeah, our latest webinar was actually held last March 27th. So it's also uploaded on our YouTube channel. So feel free to visit it. And yeah, connect with us. Join us on our meetup group. So Flutter/meetup/Flutter.ph. And you could just search for Flutter Philippines community and Facebook, and feel free to join us. We'll try to approve it right away. And yeah, if you're interested on following us across different channels, feel free to visit our website, flutter.ph. And similar with AI Pilipinas, we abide by the laws or the code of conduct of Flutter community. So yeah, I'll just share with you the link to the code of conduct of the Flutter community itself globally because yeah, it's a bit, I think it's not here on my slide. Okay, so yeah, I guess I'm done here, Ralph.
All right. Thank you
Thank
so
you.
much.
Okay, I'll stop here. Okay.
All right. So I believe everyone was able like to hear quick background as to what the two communities are all about. So if you would want to join those communities, Flutter and AA Filipinas, just don't hesitate to go visit the mentioned websites so that you can be part of the community and learn in the community itself. So let's go ahead straight to the main agenda of this webinar. So I'll be introducing a good friend of mine. So Kshitiz Rimal is an AI developer from Nepal. He is a Google developer expert on machine learning and currently a co-founder and head of research artificial intelligence for development, a non-for-profit research organization in Nepal. For the past 7 to 8 years, he has been developing software and being a full-stack developer and UI UX designer. Recently, for the past 3 to 4 years, he is involved with artificial intelligence and especially interested in a subfield of AI called deep learning. He's one of the founding members of the first community of deep learning established in Nepal. He's been developing projects around deep learning, delivering hands-on workshop on a particular technology, organizing meetups, presenting at international conferences, and delivering AI training all around the world, which includes USA, India, Singapore, China, Switzerland, Sweden, and many others. He is also a first runner-up winner in an international AI competition on disaster relief and response called Call for Code 2018, which is organized by IBM, and his project PDGR, which is on structural retrofitting using AI. He recently delivered a demo presentation and co-instructed a hands-on workshop at AI for Good Global Summit of 2019 in Geneva regarding his project called Cache Recognition for Visually Impaired, which is under the theme of AI for accessibility. He's also passionate about AI and working actively on how it can be used for the good of mankind. Let's welcome our speaker for tonight, Kshitiz Rimal.
Hello, everyone. I'm glad to be here, and thank you so much, Ralph, for such a great introduction. Okay, so let me just share my screen. Let me maybe you need to turn it off, or okay, great. Okay, let's share. Okay, so can everyone see my screen? Ralph, can you tell if you can see the screen?
Yep, I can see your screen.
Yep.
Okay, great. Okay, thank you so much again, and this is my first time speaking in Philippines, even remotely so, but yeah, great to be here, and thank you so much for having me. Like Ralph said, I'm Google Developer Expert on Machine Learning and Head of Research at AI for Development, which is a not-for-profit research organization here in Nepal. And I'm sure Ralph already shared a lot about my bio, so I'll just skip that and get to the topic. Okay, so the thing that we're going to do today is mostly talk about a field called on-device machine learning. And before we do that, let me just quickly go over how it is done and what we need to do to get this done. So before talking about on-device machine learning or TensorFlow Lite or Flutter, let's talk about TensorFlow 2.0. And if you're not familiar with TensorFlow and if you're very new to machine learning, I'll just go over brief about this TensorFlow and TensorFlow 2.0. So TensorFlow 2.0 is basically a framework, which is an open source framework created by Google, which powers deep learning models, architectures, and you can build a lot of machine learning, deep learning applications, models with TensorFlow. And the task here is not to go deep about TensorFlow or TensorFlow Lite or even Flutter, in fact, but to go over how we can quickly use these technologies today and quickly build a prototype app that can do this on-device machine learning, and how we can, in a couple of hours, we can use all this technology and build an AI-powered app. And but with that being said, let me give you a brief about how it's done, and so that you know how things are going on here, and you get the context and everything. So TensorFlow, you can learn more about TensorFlow from its official website, which is tensorflow.org. So let me just share it here, tensorflow.org. So if you can see my screen, you can see here that this is the official website of TensorFlow, and there are examples, tutorials, guides, and everything you need to learn about how this framework works. But which is not the topic today. We will be talking about TensorFlow Lite today and how we can use the model created by TensorFlow Lite and use Flutter with it to build an app. So if you want to learn more about TensorFlow and how it works, and maybe you need to dive a little bit deeper into this tutorials for now, maybe take a course or so. So if you're already familiar with Udacity, Coursera, or Udemy, you can go over there, quickly take a course there and learn about basics of machine learning and things like that. And there are many free courses as well in Coursera and Udacity to learn about TensorFlow and everything. So maybe that is if you're not completely familiar with machine learning or TensorFlow in general, maybe that would be the first starting point. And but let me just say, go to the slides and give you how much I can to, like, give you the idea how it all works and how we are going to build the project today. So to do that, you need to install Python, and Python can be 3.6 or greater, and you can quickly do so using this pip command. So if you are not familiar with Python as well, so this pip is a package installer used by Python, and you can use this pip command with install TensorFlow and quickly install TensorFlow on your system. And if you are using Google Colab, then you don't need to install it at all. You can just quickly open Google Colab, and I will also go to the Google Colab and tell you how it works. But let's just say there is a tool called Google Colab, which is an interactive notebook, and if you use that, you don't need to install it by yourself, and it's already available. But if you want to run TensorFlow on your system, you need to install it. First, you need to install Python, latest version of Python, then TensorFlow using this command. So TensorFlow, with TensorFlow 2.0, there is a uses of a new, there is uses of this library, high-level library called Keras, and this makes constructing deep learning architecture and models much easier than before. So before in TensorFlow 1.x, you need to separately use Keras and build your deep learning model. But with TensorFlow 2.0, the Keras high-level API is officially recognized and it's available as you install TensorFlow. And with Keras, you can easily and quickly build deep learning model, and which is also what we are going to do today to tell you like how it's done. So let's just say that for whoever who are not like familiar with machine learning and TensorFlow, what you need to understand is to do machine learning and deep learning, you need a framework called TensorFlow, and this enables you to create deep learning models and architecture. And with TensorFlow, there is also uses of this high-level API called Keras. And with TensorFlow and Keras, you can quickly build deep learning models. So as you can see here, on this screen, here are like 1, 2, and 3 and 4 line of code, which easily and quickly build a deep learning model. It trains the model using the data you have, and even evaluate the model. So with this 1, 2, 3, and 4 line of code, you can construct a deep learning architecture, train the model, and evaluate it. So it's easy like that using Keras and TensorFlow 2.0. So here, if you're not familiar with deep learning or machine learning in general, what we are doing here is like creating a model architecture, which has a couple of layers and an output layer. And we are compiling that model with this architecture, and we are training with this fit command. We are passing our data to this newly created model and training the model up to 5 epochs, which is in general 5 iterations. And right after training the model, we can also evaluate it using a test set. So with this line of code, we can quickly create TensorFlow model or machine learning or deep learning model using Keras and TensorFlow 2.0. So with that being said, let's talk about on-device machine learning. So whatever we have done here, this is machine learning or deep learning in general. We need to create an architecture, we need to train the model and evaluate the model. But on-device machine learning means running that model on device without the support of internet connectivity or remote access. So the model you have created, the machine learning model you have created, will run on your device without connection to the internet. So basically it's on device machine learning. So what that means is that you can train your model on device, or run the model to do predictions and classifications on device. This means the device will be responsible for handling the input, that is the data you provide, to do the prediction, computation, and even producing the output. And these devices can be mobile phones like Android or iOS phone that we use every day, or IoT devices like a Raspberry Pi or even Arduino. So this is called on-device machine learning in general. So why machine learning at the edge or on-device machine learning? So basically the main factor is the latency. So if there is no internet required or no access to the server required, then there is no round trip to the server, which is a huge point in latency. And even from the privacy aspect, you don't need to send your data to the remote server to do the classification or prediction. So it will preserve the privacy. And like I said, there is no internet connectivity required, so the connectivity issue will not be a problem. And power consumption. So internet connections, they are power hungry. So using on-device machine learning, it will also reduce the power consumption. So to do that, what we use is TensorFlow Lite. So we use TensorFlow or TensorFlow 2.0 right now, 2.x perhaps, to do machine learning, to do deep learning. But after we create our model using TensorFlow 2.x, we convert that model to TensorFlow Lite format. And this is how we do on-device machine learning. So what it can do, this on-device machine learning or TensorFlow Lite, let's say image classification, which we'll be going to cover today in this tutorial, and object detection that will localize the object that you have provided in the picture. Like in this case, there is a banana and apple, and you can see the bounding box, and with the accuracy, everything. It can also do semantic segmentation, image segmentation, which will also I'll be sharing in brief at the end of this session, and pose estimation, and smart reply, which I think we have already experienced using Google Mail, Gmail, and how it will help us, you know, to quickly write these emails and everything. So smart reply, pose estimation, and things like that. And it can support everything from text, speech, image, audio, content. So all these diverse domains are like covered, or can be done using this on-device machine learning and TensorFlow Lite. And right now with TensorFlow Lite, there are all these different architecture, machine learning, deep learning architecture that are supported. And we can quickly build our architecture using this TensorFlow Lite. If you're already using TensorFlow 2.x and you already have built your models using all this architecture, then you can easily convert that to TensorFlow Lite right now. And TensorFlow Lite is also supported in all of these languages like Swift if you're doing iOS, or Objective-C for iOS, C and C# for maybe Unity game engine, you know, Rust, Go, and Flutter, of course. And it is like there are thousands of production apps that use globally, and these are all we use it every day. You know, there is a Google Photos, Google Cloud, YouTube, Viber, Uber. They all use it globally. They all use it every day. You know, TensorFlow Lite. And right now, so this slide is a little older. So I think the latest estimation is there is 4 billion plus mobile devices right now that globally are using TensorFlow Lite in production. So creating a TensorFlow Lite model. Okay. So training a model is very straightforward. So the things that we do to train a machine learning is also covered here. Okay. So first we need to take the data. First we need data to provide to our machine learning model for the training. So we give the data, we build our machine learning model, that is the deep learning model, using this Keras high level API, and we train the model using all these strategies, and we save the model using one of the save format called either you can save your model using Keras format H5 or save model format. So this is the typical workflow that we do while training a machine learning model. So we provide the data, we build the architecture, we train the model, and after we train the model, we save them. So to create TensorFlow Lite, once we have saved that model, once we have saved that trained model, what we need to do is use this TensorFlow Lite converter to convert that same model format file into TensorFlow Lite model. So it's pretty straightforward, like you can see on screen. Once you create this TensorFlow model, you save that in save model format and use TF Lite converter, which is provided once you install TensorFlow on your system or use Google Colab, and quickly convert this model to TensorFlow Lite model. It's simple as that. So the high level overview here is that you create the model using TensorFlow 2.x, TF Keras. You save the model using either of these format, and you use the converter to convert it. So the TensorFlow Lite has a two part. One is converter and one is interpreter. So converter will convert your model to the proper flat buffer format, and the interpreter will run on your device to interpret that model and do the prediction as you require it. So using TensorFlow Lite to convert this Keras model, it's also very simple. It's with this 2-line of code, you can quickly convert your Keras model into TensorFlow Lite format. So you just provide the location to the Keras model and initiate this tf.lite.tf-lite converter from Keras model file. You execute the convert function and you save the file, and it's easy as that. Similarly with save model format, so you just provide the directory to the save model format and you convert it and you save it to the TF Lite format. It's easy as that. So let's go to Google Colab and see for ourselves how we can quickly create a machine learning model for TF Lite. Okay, so here I have, so let me just share you this link. Okay. How am I going to, do I need to stop the screen to like chat? Oh, there is, okay. More chat, okay. So to everyone, you can go to this link, and this is the link to Google Colab, and you can follow along with me or you can type it yourself as well. So yeah, so this with this link, you can open this file. This is the Google Colab environment. So Google Colab, if you're not familiar with it, this is a interactive notebook environment provided by Google for free. And using what you can use, okay, okay, great. Yeah. And using this environment, you can train your machine learning model for free using Google GPU on cloud, and even TPU, which stands for Tensor Processing Unit. And this is faster than GPU as well. So for now, for this webinar, for this tutorial, what we're going to do is import TensorFlow and build a machine learning model that is a pre-trained model, and convert that model to a TensorFlow Lite format and use that model to do our, this AI application using Flutter. So the first step is open a Google Colab, and you will see a blank screen. So to import this TensorFlow framework, what you need to do is you can just execute this line, import TensorFlow as TF. But if you need to import TensorFlow 2.x, which I will recommend, and which will be the future of TensorFlow. So what you can do in Colab is use this percentage symbol, TensorFlow_version and space and 2.x. This will ensure that your Google Colab environment will only import TensorFlow 2.x version. So let's connect our notebook first. Give it some time for, I'm really sorry about the noise because I'm from my home and there are a lot of noise out background. So if you're hearing some dog barking and all that stuff, I'm really sorry for that. Okay, so our notebook is now connected. So as you can see, if you go over here, you can see that we have a 12 GB of RAM available and 30 GB Okay, so we have 107 GB of storage available, which is given by Google Colab, and this will be available for you for like 12 hours, and you can train your model, and after 12 hours, the environment will be reset, and there is a new session. So this is what it is, and you can select the set. If you go to edit and notebook setting, you can even select what kind of accelerator you want for your system, which is GPU and TPU. So for now, we are just using a simple model. So let's just say a CPU. Okay, so is there anything in chat window? Okay. Okay, let me just quickly change that. Sorry about that. Let me get server link. Anyone with the link in view? Yeah. I think if you have a link, you can view it, right? Now, can you try again? Can you refresh the link and see if it's working? I think this will work now. Okay, let me know if there is any problem. I will check. Okay, great. Okay, so once you connect your notebook, okay, great, thank you. Okay, once you connect your notebook from this connect button, you can just write this line of code. This will import TensorFlow framework to your environment, and you use Shift and Enter key to execute a cell. So these are all cells, and you can just type it here, your code, Python code, and hit Shift and Enter, and it will import it. Now, the important thing here is that since we are not diving great into machine learning and deep learning and how we can build this all the architecture, what we are going to do today is use a pre-trained model. That is the model already available for us, and that is already being trained on millions of data set, and we can quickly use that model to do our prediction. So one of that model is called MobileNet, and this is a deep learning architecture that is already available to you from this tf.keras.application module, and with that, you can provide something called weights, and you can specify ImageNet. What this means is that this MobileNet architecture is already trained using a data set called ImageNet. So ImageNet has a big data set. It has millions of images on up to 1,000 categories of general items like a dog, a laptop, car, bus, and stuff like that. So they have like 1,000 categories of different items that are used every day, and this MobileNet architecture is now already trained on ImageNet, and which has this weight available to it. So what we can do right now is that we use tf.keras.application.mobilenet, which will allow us to use this MobileNet architecture, and we specify weights as ImageNet. So with that, we can execute it, and it will quickly download this architecture from online and let us use it. So you can also play around here. So I will suggest, if you want to do it on device machine learning, what you can use is MobileNet architecture, either MobileNet v1 or MobileNet v2. So there is also there are many architectures available here. So if you just hit dot, and you can see all these different architectures available by default using Keras applications of module. So all this architecture like this ResNet and Inception, they are very big model. They are 500 or 600, 800 MB in size, and they are not very appropriate for something you want to do on device, because generally the app sizes are very small, like 10 or 20 MB, and you don't want to increase the size of your app by using a model that is 500 MB or GB of size. So what you need to do is use a smaller model that is few MB in size. So for that, MobileNet is very good. It is very small architecture, like a 15 or 20 MB in size. You can either use MobileNet v2, which is the latest version, or MobileNet v1. You can choose whatever you like. The accuracy is a little greater than MobileNet v1 with MobileNet v2. So yeah, as these things are progressing, the accuracy tends to increase. So yeah, you can use MobileNet or MobileNet v2. It's up to you. For now, I'm using MobileNet. And once it's downloaded, now it is available using this variable. So you can hit mobilenet.summary and see all these layers that are being used by this architecture. You can see all this input shape that is required by all these layers and the output size and everything. And you can see, if you scroll down, you can see that there are like 4 million parameters that are available in this architecture. And you can also plot this architecture visually using this tf.keras.utils plot model function, and you just provide your model file you want to save as. Either you want to show the shapes of each layer and things like that. And you can see pictorially like all these layers that are available in MobileNet. So this is like a visual representation of the model that we are going to do today for image classification. So as you can see, this is quite big architecture, but very small in size, like 15 or 20 MB in size. So after that, we have included their model using this application module of Keras, and now we need to convert it. Like I said earlier, you can just call TensorFlow Lite converter from Keras model and just pass the model variable and hit convert. And if you do that, and you can quickly convert your model to TensorFlow Lite format. And after that, save that to a file. So with Python open function, you can quickly save your model as a mobilenet.tf Lite, and you write it as a binary file. And if you go to this symbol, this directory symbol in Colab, you can see our file is now available here. So this, once you save your file, this will be available here. And you can just quickly right mouse click it and download it to use it on your application. So it's to use a MobileNet architecture or a pre-trained architecture, it's simple as that, using TensorFlow Keras and TF Lite. So this is the MobileNet model building process. Now let me quickly talk about what we're going to do today for the application. So for convenience, I have already downloaded the model, and so that I don't have to re-download it again, and it's already available locally. But before that, let me quickly go over Flutter and how things. So let me just quickly go over Flutter and talk a bit about this Flutter application that we're going to build today. So if you are not familiar with Flutter or it's completely new, let me quickly cover it. So Flutter is this UI toolkit that is used to build cross-platform independent applications using Dart programming language, which is a different programming language than Python, and it's you can see the syntax is completely different, and it's more similar to that of C or JavaScript, you know. So a full disclaimer here. So I come from a machine learning background, but Flutter itself is very new to me as well. I'm no expert in Flutter, but you will see in this process that how easy it is to quickly build application using Flutter, even though you are not an expert in it. And to share a true story, so it took me only a couple of days to quickly understand all this architecture and how we can quickly build this application using Flutter. So even if you don't have anything background related to Dart or Flutter before, this will be no problem, because I will go through every little steps. And so as I'm also not that expert in Flutter domain, so maybe Joshua can correct me if I'm wrong in any part, and maybe give clearer explanation to our audience here. So yeah, so the Dart programming language is a different programming language. It has its own package system, and it has its own syntax and things like that. And before, like, you can build a product, you can build an app using Flutter, make sure that you already have a Flutter on your system. So if you are not if you haven't got any link before, so make sure you have a Flutter installed on your system, and there is Android Studio or VS Code available for you to build your apps. So if you go to flutter.dev and docs and go over here, and just basically follow these instructions from your platform of choice, you will install the Flutter on your system and use it. So if you don't have a Flutter already on your system, uh, just follow along this video, and maybe later on you can do it yourself. And by the way, the code that I'll be using today is also already available on GitHub. So if you go to, let me share you the link here. So this is the repo to the GitHub, and you can see the code that we'll be using today. The code the app we are going to build today are already available here. So even if you don't have a Flutter already installed on your system right now, don't worry, there is a code already available. Maybe you can go back to this install process later on, install it on your system, and just follow along the code and the video right now, and maybe build it yourself later on. So this code is already available for you, and you can use it. And let me just give you a glance over what we're going to build today. So, okay. So what we have done so far is that we have created a TensorFlow Lite model that is trained on MobileNet architecture and is already trained on ImageNet dataset, and which can support up to 1,000 different categories. So what it means is that if you provide a picture to this model will classify your picture based on 1,000 categories that are available to it. And these are all general purpose categories like a bird, cat, or person, or things like that. And so let's talk about the Flutter app that we're going to build today. So this is the mock-up of the app that we're going to build today. So as you can see here, so if you are not familiar with app development or Flutter in general, so let me quickly cover what we are going to build and how this will work. So the UI looks something like this. The app that we're going to build today will look something like this. So as you can see here, we have an app bar that has a title of this app, and we have this image preview window as well. So whatever the image you choose, either from camera or gallery, the preview will be shown here. And using our machine learning model, the MobileNet model, it will also give prediction here. And the hierarchy of the app is something like that. This is very, if you're not familiar with Flutter, this will be very new to you, but I will go line by line, and this will, by the end of the video, hopefully this will be very familiar to you. So these are all the hierarchy that we're going to build today to build this UI. So using Flutter, we will build this UI for Android application, and this application will use TensorFlow Lite model that we just created earlier to do the prediction. And this app can take input either from camera of your device or the gallery, the images that are stored on your phone. So with that, you can do prediction, image classification. And the source code for this application is already provided here. So if you go here, you can see all the source code that we're going to build today is already also available here, and you can download it and use it. So with that being said, what you need to do first is that, okay, open up Android Studio. So if you have already installed Android Studio, and if you have already installed a Flutter plugin on your Android Studio, you will see something like start a new Flutter project. So click it and go with a Flutter application. And let's just say, okay, TF Lite. Okay, TF Lite. Oh, TF Lite. Flutter demo. For now, just use it as a description. Provide a directory to store our project. Hit next. These are all good. Hit finish. Let's just wait now to create the Flutter project. So for any beginner, I think the Android Studio is very easy to follow and build this Flutter application. It's like they give you like code hinting and everything. So if you're fairly new to Flutter, like I am, it's very easy for you to build a Flutter application using Android Studio than the VS Code, which I find. So maybe in your case, if you're already familiar with VS Code, then this will not be an issue. But for me, I think the Android Studio is quite easy to use for me. So yeah, this is what I prefer. Okay, so once you do that, the Android Studio will create a file directory and a folder structure already for you for your Flutter project. So here, this is the file and folder structure that is generated by Android Studio for the Flutter project that we're going to use. And as you can see, this is the file. This file is located in this lib folder. So let me just quickly go over all this directory and tell you what it all you know, do in general. So the Android folder is specific to the Android platform, and which we will be running our project on today. I will not be covering on iOS because I don't have an iOS device, and sometimes it's not that proper to using image and camera using a simulator. So I'll just use Android, and I think with minor tweaks you can easily port that to your iOS device as well. But for this demo, for this webinar, we'll be deploying our application on Android device using Flutter. So we'll be basically, if we need to do any platform related changes to the Android system, we will be going to this directory and tweak it there. Similarly, for iOS system, if you want to tweak something specific to iOS system, you go over to this directory and change stuff here. Same with the Android, like I said. And this lib directory is where we will be creating our Dart code, our Flutter code, and where we will be mostly spending our time. For the sake of simplicity, I'll be just using one file today, which is this main.dart file, which is provided by default, and this is responsible, and this is the entry point to run your application. So, and this is the boilerplate code that is provided to you once you generate your project. So we will be removing this code and writing our own to build our application. So let's just check if it works or not. So right now I have already connected my mobile phone here, and I will just hit this run command, run this application, this demo application for our device. And so that you can also see what is going on my device, I have this visor window already open. You can see the preview on my phone, and we can see what is going on here. So right now you can see the screen on my phone, and this is the app will be directly installed on my phone, and you can see how this will be run in my phone. So let's just wait to run it on my phone and see if it works or not. So this is the demo application. This is the boilerplate application that once you generate a new project using Android Studio, it will create this boilerplate code, and you can run your application on your phone. This is a very simple application that will just allow you to create a counter, you know, and let's see if it's working or not. So let's just wait for a while. And as my system is quite old, it takes some time for me to compile all this code and run it on my device. So bear with me. I think in a couple of minutes it will be done. So before that, let me just quickly go over to how we are going to build this application. So the screen here is that, okay, so this is how we are going to build this application. So these are the step-by-step process that I have written down so that it will be easier for us to code the system. And for the sake of simplicity and even the time constraint, what I'll be doing is that I will not write every code line by line, but instead I will use the GitHub repo that I have provided already and explain everything line by line, and maybe just copy some of the stuff from there and explain to you and build this new project. And the UI and this UI thing that we are going to build here, this will come only at this latter part of the system. So first, what we need to do is import packages that are relevant to our project. There's something called run application method, which I'll be covering shortly. And we need to create something called Stateful Wizard, which I'll also cover. So these are all the steps that I need to do today to create this application. So let's talk about packages for now. So as the application is building, let's, okay. I think this is okay, going good. Okay, great. So far, no error. So let's just quickly go over to the package system. So the pub.dev is the place where you need to get the URL for your packages. So for this project, we are mainly going to use two external packages, that is TF Lite, which is compatible to our Flutter code, and Image Picker. Image Picker will allow your application to pick images from gallery or camera. So if you go to Android Studio now, okay, so I think the application is already compiled to our mobile phone. Let's just see the visor window. Okay, see. Okay, so this is the application. I hope everyone can see the screen. Okay, I'll just move it over here so that you can see the screen properly. Okay, so this is the application window. So if you click plus plus, this will just do a basic counter application. So this is like a to-do application in Flutter. Once you generate a project, this will, so far this is good. So it means that our system is running so far. So let's just stop this code for now. So we're making a lot of changes here. So what we need to do is that let's just get rid of all this code for now, because these are not what we're going to use today. So what we'll do is just remove this code for now. And okay, let's follow our steps. So what we need to do first, import packages. So like I said, we need two packages, TF Lite and Image Picker. Let's head over to our Dart package manager here, pub.dev, and let's search for TF Lite. Okay, so you can see the top result here. So to install it, you can just go to installing option there, and it says add this to your package popspec.ml file. So let's just copy this line of code, copy it, and head over to our Android Studio, go to our popspec.ml file, which is available in our root directory here. So let's just scroll down to dependencies, as you can see here. Let's just go there, paste it, simple as that. Now let's import our another package, which is Image Picker. Image Picker. Okay, so this is the first option also. Go to install. Let's just copy it, paste it over there. Okay, save the file, head over to Dart, and as you modify your popspec.yaml file, this will get notified to you, like get the dependencies. So you just click it, and the Flutter will get all this dependencies that you have just provided to it, and it will use it for your system. So this is done. Okay, so before we head over to coding our application, we need to take care of a few steps. So what we need to do is that we need to first use our TF Lite model that we have just created to this Flutter directory. So to do that, let's just go to this popspec.yaml file and head over down here, which is called asset. So this TF Lite file and the labels that it uses, they are basically called assets. So what we need to do is we have to create a new folder where all our assets will be available, and use our TF Lite model there for this application. So let's just get rid of this line and let's just remove it. So let's just say assets. Okay, so what we are doing here is that we are just providing a point. We're just telling our application that look for this assets folder in our root directory, and this is where all our assets will be stored. And in this case, in our case, this will be TF Lite model. Just save it, head over to main, get dependencies. Although we didn't add any dependencies right now, let's just do it. And okay, so like I said, I already have a model file downloaded for the use. So these are the model file. So this is the MobileNet TF Lite file that we just created. And on top of that, we also need to provide a file called labels.txt, and this is this 1000 categories that is available to our model. So this file, you can use it from the GitHub that I have provided, or else you can go to Google and search for MobileNet labels.txt, and you can quickly see the txt file on GitHub of TensorFlow repo, and you can download it. But let me warn you a bit. So So if we go to mobile net labels and use it like that, you will find this link at top of it. But here is this tricky part. So I'm not entirely sure why it's not working. So as you can see here, there are 1001 categories, and the first category is background. So this label.file will not work and the application will crash. So what we need to do is get rid of this first line and move this tense line to the first category, and basically make our labels like this. So the tense will be at the top, uh, and the harp will be at the left. So this is 1000 category. We just need to edit this label.txt file and get rid of this background label to make it work. So which is what I have done here. So even if you use mobile net labels file, just edit it to make it look like this one and use it as a label for your mobile net model. For now, I have already provided in the GitHub repo. So if you just go to this asset folder, you can just basically use these two files off the shelf, no need to edit, it will work. So let's just copy this folder, and this is our new repo for our Flutter application. Let's just paste it on the top, because this is where our assets will be, like we said in our popspec.yaml file. This will be available in our root directory. So if you go here, this is updated now, like we have just copy pasted here, and as you can see, labels and mobile net are available now. Okay, so far so good. So I'm sure, I hope like everyone is hearing me correctly. Is everything right there? So are you guys hearing me correctly, or do I need to make some changes?
Yeah, I think we're good.
Okay, great. Okay, thank you. Okay, so after we do that in our popspec.yaml file, since our application will be running on Android system, we need to make some few adjustment on our Android directory as well. So so what we need to do now is that head over to this Android directory here, head over to app and build.gradle file. Let's just open it and scroll down a bit. So to work your application on your mobile phone, what you need is minimum SDK version to be of 21 instead of 16. So by default, there is a 16, but you need to make sure that your minimum SDK version is 21. Then after that, head over here. And if you go to this, let me just quickly go over here and TF Lite again. And head over to there. You can see this line of code here. So basically copy it and just paste it over here, which means is that while running your application on an Android device, these two file extensions, these two files that are available in assets will not be compressed, and this will work as it is supposed to work, and things will go smoothly. So we just need to provide these two exceptions here. So no need to compress here TF Lite or Lite extension files. So that's it. Just save it, close it, popspec also for now, close it, and this will good to go. Now we will only need to focus now on our main.dart file. So let's head over to our steps here. So first we need to do import packages. So let's just import packages that are required to our system. So these are image speaker and TF Lite packages on top of all the Dart related packages. So let me just quickly paste it over here. So what I have done here is that for input output of our system, we need Dart.io package, which is available by default, and we need material Dart package, which will allow us our application to use material design on Flutter. We need some services from Flutter, and we need our TF Lite package, which is just installed it, and image speaker package, and that is it. Step one completed. Okay, so let's head over to execute run app method. So, okay, let me go there. Okay, so for this, let's just call it my app for now, and we'll edit it later on. So what we need to do now is that we need to create something called stateful widget. So in Flutter, everything is a widget. So let me go over to the UI that I used earlier. So as you can see here the app bar, the text widget, image, flat button, everything you see on this screen are something called widgets. So Flutter uses this mechanism to quickly construct all this layout in our screen. So whatever you use to build something on your app, on the screen, to paint it on the screen, they are by default a widget. So what we need to do is first is to build this stateful widget. So in Flutter, there are two types of widgets, stateless and stateful widgets. So which basically means that in stateless widgets, there is only one time building of your UI, and the properties that you use for your stateless widgets inside your stateless widget will not be mutable and things like that. But with a stateful widget, you can rebuild the UI or reconstruct or repaint your UI as you fit, and you can create your own private variables. You can tweak your UI as per the values in that private variables, like you do it in a class, So basically there is more flexibility in terms of what you see on the screen or how you paint things on your screen on your mobile phone with stateful widget compared to the stateless widget. So the simpler UI elements like text and images, they are like a stateless widget. So there are not so many building processes happening there. It will just paint a text and things like that. But if we need to build something like this complex UI, we need to provide a stateful widget where there will be private variables, where there will be predictions that are dynamic. The image preview can change as we change the image and things like that. So for this dynamic behavior to build things there, to understand it in a very high level way, we can use this stateful widget. So this is just a simpler explanation that I have used to get you intuitive idea on what is stateful and stateless widget. And I'm sure you need to further, dive into Flutter ecosystem and Flutter tutorials to learn it in more depth. But let's just say, for the sake of this webinar and for the sake of this simple application, we are going to use a stateful widget, something called stateful widget, which will allow us to dynamically change our UI as per the input we will provide, and we can make it a very flexible and things like that. So let's just say for a complex and dynamic behavior that uses the private variables and things like that, we use a stateful widget. So in Android Studio, it's very easy to create a stateful and stateless widget. So basically, you just type ST and L, and this will allow us to create a stateless widget. But since we are going to use a stateful widget, let's just ST and F. Okay, so as you can see, these are all autocomplete, and you can just hit tab, and this will create all this boilerplate code for a stateful widget. So once you STF, you will hit tab and you will get this boilerplate code, and you just provide, let me just do it again, stateful. You just provide name for your stateful widget. Let's just say for now, detect. So the class called detect will be our stateful widget, and let's just use it to run our application. So to run our application here, by default in our boilerplate code, they just use this my app function. But since we are going to use a material UI and things like that, we need to make a few changes here. So let me just quickly copy some stuff from our GitHub repo, and I will explain what it does. So let's just say, just get rid of this right now. So your main dart file is your entry point to run your application, and for in that as well, this run app is the main point where the application gets executed. So you provide this in this run app method what you need, what your application needs to enter first. So here we are going to, since we are building this UI from this detect detect and detect state class, we need to provide here. So for now, let's just paste it here. So what it does is that, let me just remove it. So here, so what I have used here is that I have used something called Material app. This is a widget provided by Flutter that uses Material UI. And as you can see here in this UI, this whole application will be in a theme of material design. So for that, we need to provide something called Material app at our parent root, the structure. So if you are familiar with document object model, DOM, HTML and stuff like that, you will be familiar with this approach. So this will be our root node, and everything inside here will be our the child node of this Material app. So what we need right now is we just provided a widget which will allow our application to use material design. So what you do first is that inside this run app, you use Material app, and in this home property, we provide the name of the function that we'll be using our UI to build. So in this case, detect. And as you can see here in our earlier application, let me just quickly go to the visor. You can see there is this little sticker here, this flag here, which says debug. So if you're like me and if you don't like this debug sticker while building your app, you might need to remove it. So to do that, you just need to add this property, debug, so check mode banner and set it to false. With that, this banner will be gone. So after that, then let's just head over to here. Okay, so what we have done so far is use Material app. We use a detect method or detect class that has used as an entry point for our application, as a home for our application. We have removed the debug banner from our application. So from now on, whatever we're going to code will be inside this one. So if you create a stateless widget, STS, this will be only one class created by the Android Studio, and this is where all you will need to do. But if you create a stateful wizard, like in our case, this will create two classes. One will be this one, which will create a state based on this class, and we will mostly be doing our code here in this class. So all this private variable that we're going to use, all this mechanism to load our model, to do prediction and to paint the UI, all will be done in this single underscore detect state class. So this is where we'll be working. So let's just save it. Okay, let's just head over to our notebook and see. Okay, so far we have created stateful widget. Now we need to create some private variables that will record the responses, predictions, and so forth. So let's just add some private variable to our code. Okay, so what I have done here is that I have created one private variable called image. This will act once we load our image from our UI, this variable will store that image here. And we have also provided image width and image height variable. This will store the height and width of the image we have selected. And as you can see here, the image is a file format, and this image width and height are of double format. This will be just the numbers that will represent the width and height of the image. And for the recognition that our model does, the prediction that the model that we will load will do will be stored in this recognitions variable. You can in Dart, if you are unsure like what type of file, what type of type will be of your variable, you can simply say var and this will do automatically. So in this case, I'm pretty sure this will be of a double and this will be of a file extension. If I'm not sure the recognition, the type of this recognition, I can just simply say var. I'm not sure if this is a best practice, but this seems to be very easier for me to understand things. So that's why I use it. So maybe if there is a better approach to this, please suggest me and I'm happy to edit it as well. So let's just go to our notebook. We are done with, let's just do this asterisk. Done with import packages, done with run app, done with stateful wizard. Now, and we are also done with private variable. Let's just create a method now that will load our model, our TF Lite model that are stored in our asset folder. So for that, let's just head over to our Android Studio and create a model called, create a function called load model. So here, as you can see, I have created a function called load model, and this is an asynchronous function, which means that it will take some time to load this external file. So basically, if you are dealing with some internet connected responses, you know, if you are trying to load something from a directory and you are unsure how long this will take, it's better to make it a synchronous function and use it there. So as we are loading our model from this directory called assets, we need to provide it as a async method, and we'll just say load model, and we provide it as async method. And to ensure that the so here I have called something called tflite.close. So this tflite is imported from this top packages here. So why I have used tflite at top of the code is that as you create your application and you debug it repeatedly, it is sometimes like you might need to your earlier version of tflite model might be running, and you might need to close it before you need to load another model. So to ensure the error that will happen because of the earlier model being running, we need to first ensure that we first close all these tflite model instances and quickly load a new one. So just to do error checking mechanism, you know, to ensure that all this, there are no further tflite model being run around, we just run this close method upfront, and then load the method. So first close it and then let's try it. Okay, so to load our model, what we need to do is use tflite.load model, simple as that. And inside there, we just provide two parameters, that is one model and one is label. So inside model, we just provide directory to our mobilenet tflite file, that is assets/mobilenet.tflite, and in labels, assets/label.txt. And we store the response either it is successful or not while loading the application, the model, we just stored it in this res variable. And if the model is success in loading if this function is success in loading the model, the response will be success, else this will be failed or could not load the model and things like that. And if somehow there is an exception that is raised due to fail to load this model, we can quickly print that as well. So with that, we can construct a function that will load our tflite model. So it's simple as that. You just need to know this tflite.load model and provide model location and labels. That's it, simple as that. So once it's done, let's head over to another task, that is create a function that will do prediction on our images. So far we have created a function that will load our model. Now let's write a function that will do prediction on our images. So to do that, let's just head over to our Android Studio and write this function. So let's just go there and okay. So to do that, we have created here a predict function that will take image as input, and this will do tflite.run model on image to do the prediction. So we have load the model using tflite.load. Now to do prediction on using that tflite on our model, we need to provide tflite.run model on image. And with that, what we need to provide is path to our image, that is this image dot path, which is required because it will know how the image will be like passed to the model. So simply, if we provide image as a parameter, and there is this image as an argument, and with this image there is a property called path, and this will give the idea of where the image is located. And if you want to do normalization on your images, you can provide image mean, image standard deviation value, and this will basically normalize your image while doing the prediction. And if you're familiar with machine learning, then you might be familiar with this normalization task with mean and standard deviation calculation. If you're not, maybe first you need to have some basic idea on how we do pre-processing and stuff like that. So it's a very standard practice in machine learning to first do pre-processing on your image before doing the prediction. So from this property, from this parameter, we are simply passing a mean value and standard deviation, so that the image that we have provided to the model will be first normalized, then only prediction will be done. And with this parameter, what we are doing is that, so by default, if you pass image to your TF Lite model, it will give you top 5 predictions. That is, on the basis of confidence level, the model will give out 5 output that will signify which category or which class your image belongs to. So for the sake of simplicity, I have only limited that to 2. You can use it to 5, you can use it to even 1, it's up to you. So but the most confident prediction is what we need. So or whatever, you can use it 5, but for 2. So with what this means in general is that once you provide an image to the model, the prediction function on this model will give out 5 predictions based on the confidence level. That is, let's say if you pass an image of a dog to a model, then the 5 prediction can be like first prediction where the model is like 90% confident that this image is of a dog. Then there will be second prediction where the model will be slightly less confident that this image can be of a cat, or third prediction can be of this image can be of a bird, and so forth. So you can get this idea. So you can provide threshold value, how much precise you want your prediction to be. So by increasing or decreasing, you can play with the threshold value here. So by default, it's 0.1. I have also used it to 0.2. So what you need to do, what you need to keep in mind right now is that for now, you just need to load the model. You just need run model on image, provide the path, and maybe provide all these parameters by default, and not worry about it for the sake of this tutorial. And once you do that, this is also a async function, so this will take some time to do the prediction. Once the prediction is out, it will be stored in this recognition variable, and we can simply print it on our console to see if it's working or not. And once the prediction is on this variable, we can also save this to our private variable of this class, that is this underscore recognition. In case of Flutter, in case of Dart, if you have a class and if you have a private variable that needs to be updated, you need to use it, the set state function, to update this private private variables, so that so that every time you update your parameters, every time you update your private variables, you also rebuild your UI based on that, which is what we need right now. So once our model predicts certain thing on our image, we also need to provide that prediction on screen so that we know that what is the prediction of that image. So to do that, we also rebuild the UI, and this is done only when we update our private variable using this set state inside the set state method. So this is what we need to keep in mind here. What we do right now is that we load the model, we run our image on the prediction, predictions are being made, we set that prediction to our private variable by using set state, which allow us to rebuild our UI based on our prediction. So, okay, after that, let's head over to another point. Okay, this is also done. Okay, so far what we have written is the predict function that will run prediction on the image that is provided. But we also need to provide a function that will send image to this predict function. So to do that, let's write a function that will send our image to this predict image method. So to do that, let's head over to our Android Studio again. And here, let's just okay, this is pretty okay, great. Okay, so this send image function. So this will send our image that we select to this top predict function. So you can also like wrap all this thing in one function, but for the sake of understanding how things are working, I have just broken down into two different functions. It's up to you how you want to write your code. This is just how I choose to write it. This is not a standard practice or anything. This is just how I felt, you know, very natural to do things. So that is what I did here. So you can try your own approach and maybe merge these two functions in one, and it's up to you, I think. So here, what's going on here is that first we need to select the image and see if the image is null or not. So what it's doing is that once you load your application for the first time in your mobile phone, the image will be set to null. That is, if you haven't chosen any image upfront, you don't need to provide anything to the predict function. So basically return it. And if you have already selected an image, then only provide that image to the predict function. And once the prediction is being made, what you can do is that you get the image width and image height from the image you have selected. So using this file image function, file image approach, you can resolve this configuration. You can resolve the height and width of your image, you know, and basically what it's going on here is that you use file image dot resolve, and the whatever image you have selected here, it will just get this width and height from that image and store it to this our private variable, this image width and image height. And we are also storing the entire image as well to this private variable that we have written here. So this is what's going on. And to update the preview, once we select the image on our screen, we also need to set the set state so that the image, the UI get refreshed once we select the image and we can see the proper output. So let me, if you're confused, let me just go over here. So as you can see here, this is the UI. So once we select gallery or camera and select the image that we like, we need to see the result here as soon as we select the image. And with this set state, what it's doing is that once we select the image, we need to rebuild the whole UI or maybe the portion of the UI to reflect that change. And this is done when we call this set state, and this will update the UI based on the changes on our private variable. And this is what we are doing here. So far what we have done is that we have created a function to load our model. We have created a function to run prediction on the image that is sent to it. And we have also written a function that will select the image, that will pass that image to the predict function. And once the prediction is being made, we can simply resolve width and height of the selected image and the image itself. And this is so far what we have done. And let's go over here. This is also done, this is also done, and this is also done. Now let's write two different functions that will allow us to select image from gallery or camera. So this is what we need. Let's just copy this one from the gallery. Okay. So select from gallery. What it does is that we have imported a package called image picker. So using this package image picker, we are picking image with source is gallery. So simply by providing something like image picker.pick image and the source is image source gallery, we are selecting the image from the gallery. It's simple as that. It's simple as this line of code. This single line of code will allow us to pick an image from the gallery. And what it does, so if the selected image, so So once we select the image, and if we fail to select any image from the gallery, the image will be null. So if the image is null, and if we haven't set any gallery image, we can simply return it. And if the image is not null, then maybe we can send that image to send image function that we have just created above, so that it will be sent to the prediction, and we can get the image height and width and the image itself to our private variable. So far, so let's head over to the UI. So when I click this gallery button here, this function needs to be invoked. And what it will do is it will allow us to select an image from the gallery. And once we select that image, we will send this image using the send image function for the prediction. And once the prediction is being made, we resolve the save the recognition or the prediction in our private variable, and we also save image height and width and image itself to our private variable, so that we can display it properly in our UI. This is what is going on here. So this is select from gallery. So here, as you can see, I have this empty set state being invoked here. So this is very, so I'm not entirely sure, but what is going on is that if I remove this line from here, so it failed to reflect the changes as I pick the image. So to avoid this this little catch, I have just written down this empty line here, which will just rebuild the UI based on the image I have selected, even if I haven't like updated any variable here. So what this will do is that once I select this image, so far the build process will be rebuilt, and the image gets reflected on the UI. And if I remove this, I'm not sure, maybe Joshua later on can help me identify the error, and maybe so that so if I remove this, it wasn't working properly. So just to make it work properly, I have written here. Okay, so let's just head over to, okay, so we are done with select image function from gallery. Now let's write a function for select image from camera. And like in this case of image picker from gallery, the select image from camera is also very straightforward and just a single line of code. So basically there is no much of a different here. So instead of gallery, you just write camera, and it will select image from camera, and simple as that. And make sure these two functions are also async, because these are all asynchronous operations that you need to select the image and so forth. So make sure these are of proper type. Okay, so once we are done with that, let's head over to init state function. So let me just quickly share what this init state does and why we need it, and maybe the overall life cycle of the Flutter application UI and things like that. So let me just first paste it here. So while building in a Flutter UI, there are two things that you need to keep in mind. One is init state function and one is build function. So for the first time you initiate your widget, so for the first time you invoke your widget, instantiate, this function gets called, and you need to provide everything that you need in your UI once your widget is initiated, and once you need to maybe you need to set proper value to certain variables, maybe certain you need to load something up, so if there is something that you need to do once your widget on your screen gets initialized, you need to provide here in your init state, and this is done once for the first time. And so this is whatever, so what we need in our case here is that once we open this app or this UI, first what we need to do is load our model on the background. So that's why I have provided this load model function that I have written here above to this init state. So for the first time when the app gets launched and the UI is painted, this init state function is invoked, we need to load the model, and that is what going on here. So everything you need to do for the instantiation process, you need to provide here in this init function. So that is all that is going on here. And okay, so once you're done with init function, so let me just quickly paste a function over here, and let me quickly paste a function over here, and maybe come later on to explain what is going on. So okay, so let's just head over to build function. So maybe it will be less confusing for you, because I'm sure if you're completely new to Flutter, this will all be already overwhelming, and machine learning and Flutter. So let me just slowly go over, and maybe this will set a pace. So let's just head over to build for now. So far, let's just go to notebook. So far, we have imported the packages, run the application, the entry point of our application, and tweaked it so that it will load the proper class that will be responsible for our UI. We have created the stateful wizard that will be run by this run app method, and inside that we have set our private variable. We have created a function to load our model, credit function, send image function, select image from gallery, camera, init state, and so forth. So let's skip this for now, and let's go to build method, which we have already here. So this is the method that will be called every time you set a state, or every time you you change the value of your private variable using set state method. So while you see an app running, if you change something of your private variable, then this method will be again recalled. So throughout the lifetime, the build function will be called again and again based on the changes of your private variable. So here, if you run this send image function, and if you set state, then this function will again be recalled or reinvoked. So this is so this init state will be called once you initialize the widget or the UI on your screen, and this will be run time to time based on the change in your parameters, change in your private variables. So whatever we are going to paint on the screen, so whatever that you can see here, this wireframe, everything that will be, so everything you see here is written here in this build function, inside this build function. So if you see this hierarchy here, so far we have already covered material app on our run entry point here. So run app entry point here. So what we need based on this hierarchy is this whole UI should be inside a widget, something called scaffold. So this scaffold wizard will allow us to create this app bar, this text, this buttons, this image preview, and everything. This is basically a container. And there is also another wizard called container, but for now we are using scaffold. So this will contain everything. So just head over to this function and write scaffold. So if you just type SCA, and you will see the autocomplete, and you make sure you have a semicolon, and that's it. So let's head over to here. So let's say scaffold. Under scaffold, what we need is app bar. So let's say app bar. So app bar is first provided as a property. Now inside that, there is also a widget called app bar. So this is responsible for the app bar on your UI. So here, maybe title, and let's just say Flutter X TF Lite. While there is sorry about that. So you cannot just simply you cannot just simply write a text here. You need to provide a widget that will print the text. So for that, to print a text on your UI, you need another widget called text in Flutter. So like I said, everything is a widget in Flutter. So even to print a text, you need a widget called text to print a text. So far, so good. So let's just run this app and see if it's working properly or not. I have something on chat. Yes, thank you, Joshua. Okay, so while it's being compiled, let's just write something else on our screen. So let's head over to our UI. And okay, so far what we have covered is we have created a material app that will be the whole app that we are running. Inside that we have a scaffold, like it will act as a container to our UI elements. And inside the scaffold we have app bar. This is basically the app bar. This top, which will be a title for our application. And inside the scaffold we have also something called list view, and inside this list view we are basically using all these elements here. So let's just okay, we have some errors because of this TF Lite. Let's see if it's working or not. Okay, let's open the visor. Okay, so far so good. As you can see here, we have a app bar and it says Flutter XTF Lite. So this is what we have built so far. And okay, what you can do is like in case of our UI, we can center it using something called center title, I guess. Center, yeah, so, and set it to true. Okay. And if you go there, yeah, you can see. So the Flutter also supports something called hot reload. So what it does is as you make changes inside this build function, inside this widgets, you can quickly see the changes here. So let me just quickly turn it off and let me drag it here. Okay. Okay. So if I set it to false and save it, this will again be reflected on left. This is the default behavior, but in this case we need in the center form, so we just set it to true. So inside this build function, inside this wizard, whatever you do, you make a little changes, it will be automatically be reflected on your UI, and this is because of this hot reload feature. So we have app bar. What we need is a list view that will allow us to add these little elements, these elements in our app. So to do that, we need to provide a body. And this is the body of our scaffold, this container. And inside this body is all our elements. So if you go back to this, if we go back to this UI, we can see that we have a scaffold, we have app bar, and in body, we have all this prediction, image preview, and buttons. So, and this is also the parent widget is here is list view. So let's just call list view. As you can see, the autocomplete here, and just hit enter, and bam, this is how the list view does. And inside the list view, what you need is called children. So a list view contains list, and list, in this case, list of widgets, and these widgets are text, that can be images, that can be buttons. So there could be many list items, and they are basically set as an array of list of array of widgets. And basically we provide a children parameter and provide it as a list of array of widgets, and inside that we just write whatever we need. So in this case, first what we need is a text widget that will say something like prediction and class name. So let's just head over to here and create a text, and it will say something like, for now let's just write it predictions goes over here, give a comma, and what we need another is image. So for now, let's just create another text and set it as a placeholder. Image goes here. This will be replaced by an image in a while, but for now, let's just place it as a placeholder. And what we need now is our buttons. So as you can see here, these buttons are placed like side by side, and this is what very unintuitive for me in Flutter, because so far when we deal about columns and rows and things like that, what we believe is that the number of element in a table are the rows, and we visualize it, at least in case of mine, you know, I visualize it as a number of rows, could be like a number of entries in a table. But in this case of Flutter, it's basically the other way around. So columns are like rows in Flutter, and rows are like columns in Flutter. So when we need to provide you know, certain elements, like in this case side by side fashion, you know, in a UI there is camera and right next to it there is gallery, we will visualize it as a column. You know, there's a first column here and there is second column here. But in this case in Flutter, we need to provide it as a row, and this will be the first element of the row and this will be the second element. And these elements, this prediction, image, and this will be in a column format. Okay, so I think we are running out of time. So let me just quickly get over and maybe give you some idea again. Okay. Okay, so let's just head over to here and let's just create a row element. And in this row, what we need is are the children, and these are also the elements. And as you can see here, this entire thing is a row. This will be covered in a row, and there are two elements, so they are the children of this row. So here what we need to provide are two flat buttons. So in case here, one is flat button with icon, maybe, you know, so let's just call it that. And here let's provide icon with, let's just say for now on press to be something like this for now, and it's just an empty on press function. We'll replace it with something else later on. And oh, but we have already written a function, so let's just call it select from gallery. And oh no, first will be select from camera. So let's just call it select from camera, because this will be the function button responsible for opening our pick image from camera action, you know. So the icon here we need is of the camera. So icons dot camera. So you can set camera or camera alt. In this case, I have just used camera alt, and you can see here this little preview here. This will allow you to see what's the preview here. So let's just keep it there for now. Let's just label it with a text called camera. Okay, and now let's just copy this, because we need exactly that for our gallery. So, okay, and gallery, and maybe here we need something called file upload to give more better intuitive idea, you know. So let's just save it. And let's just head over to our visor. And as you can see here, we have app bar, we have two texts that we have written, and we have a camera and a gallery. So far, so good, right? Okay. So I haven't done any styling in this part, but in the GitHub repo that you can see from the link earlier, you can see all this kind of styling, like in this case, like there is this styling of this, all this thing. So I haven't, for the sake of time, you know, like I haven't included any styling here. So what we need now is that we need something to show here in our prediction, instead of just a plain text that will, once we select an image, we will see the prediction and we will see the image preview. So for that, what we need is we need to write a function that will be print a prediction once we select an image. So for that, I will just head over to my GitHub repo and use this function for now, and I will explain what it does. So let's just see here. So as you can see here, I have pasted a function here called print value. What this will do is that it will check if there is a prediction, if there is a recognition done, then it will print the recognition based on the recognition we have received from the model. And if we haven't selected any image, or there is a prediction that our model could not understand, it will say something like could not recognize. So we have a three condition here. If we haven't selected anything, if we haven't selected images from our app, which is the case right now, there will be no prediction. So it will be just empty text. And if we have selected an image, but the model could not understand the image, it will say something like could not recognize. But if we have an image and there is a proper recognition, this will print the text saying the recognition. And all these paddings and style, these are all the styling parameters that I have provided to just to make it look good. So what we need right now is just something like this. And for now, let's just head over to here. And instead of just a text, let's just see this. Okay. And we need is recognitions. So whatever the recognition happened, this will be stored in this variable. This is the private variable. So that is why I have provided here as an argument. So after that, what we need is a, okay. What we need is an image to get preview. So before we preview an image here, before we replace this thing, what we need is a width and height from our image, and we need to reshape it in a proper format, like resize it. So the image we select from our camera or our gallery could be of a different dimension. It could be bigger than the UI, the screen size of our application. So what we need is we need to modify that width and height of our original image so that it will get properly fit into our UI. And to do that, what we need to do is utilize this something called context. So this context, if we use material app from this run app function, this material app will provide something called context. And what it does is that it will tell our UI like whatever the position that we are in a UI. So let's say if we want to print a text or image, it will give the idea like where in our UI hierarchy this image is presented. Basically a context on our screen where the element is located, So basically like in a very intuitive way, it's called context. So it's basically says the context of the element that is situated in our screen. So how we need to resize this image that we select is that using media query function. So media query will allow us to get a size of our screen. So in this case, as you can see here in the visor, okay, let me just unlock my phone. Okay. Okay, so here, this UI, this has certain size. So this has certain width, this has certain height. So first what we need to do is get the width and height of this UI and reshape the selected image that we have selected so that it gets properly fitted here. So to do that, let me just quickly copy the code that I have already used in my GitHub repo, and maybe you can use it in your code later on. And let me just quickly share it, what it does. So what it does is that first, based on the screen size, width and height, it will get the size from it in size type. If we have a image is already selected, and if we have already selected our image, then we need to get the height and width of our image. First we need to get the width and height of our screen using this and set it to our final width, height, final W and final H variable. So here I have used this context variable to get the height and width of our screen. After that, once we have selected the image, we have extracted a proper width ratio and height ratio based on our screen size and the width and height of our image. And basically what we have done is that we have reshaped or rescaled our image for the preview, so that the image preview is like fitted in our screen. So basically what we are doing here is that first we're getting the width and height of our screen, this whole UI app. Then we're using our image width and height and get the proper width and height ratio, and use that ratio to reshape the height and width of our image so that the image will be like displayed properly here. So you can also avoid this whole step and basically maybe like reshape, like concrete integer or your floating point value, and don't care about width and height ratio and things like that. But it just seemed to be like a proper way to do for me, and that's why I did it. So you can basically reshape it your own way, and maybe you don't have to utilize all this media queries and stuff like that. It's up to you entirely. So there is no problem with that as well. So after we have extracted the width and height of our screen and our image and reshape our images that could be fitted in our screen, what we need is we need to print that image preview. So for that, let's just head over here, and instead of this text here, what we need is we need image. So for that, let me just quickly write this down. Where's my mouse? Okay. So this is a very long code. So what it does is that if we haven't selected any image, so in this case, so it should say something like select image from camera or gallery. So if the selected image is null, so if in case the first time we are opening our app, if it's null, then we are simply printing out selected image from camera or gallery. And once we have selected an image, maybe center that image and print it on the screen with the final width and height that we have provided. And it's simple as that. So let's just save it. And as you can see, the changes are already reflected on our screen. And so far we haven't done any prediction. So there is an empty thing here. And we haven't selected any image as well. And so there is no, so there is a message called select image from gallery or camera. So let's select an image from our gallery. So let me allow our application. So let's just hit images. Let's go to my Instagram. So here I have my images here. So let's just select this image, this of my dog. So as you can see, this is doing perfectly. So I have selected the image of my dog, and it says prediction Labrador Retriever, which is the correct level. So what it's doing is that when I click this gallery button, this function select from gallery is invoked. It will allow me to select an image from a gallery. And once I hit that, this image is sent to the model, this predict function that we have written earlier. And with that, it gets something recognition, this recognition or prediction from this image, which is Labrador Retriever in our case. And once we do that, the images are printed here, and labels are, the prediction are printed here. So far this is this is what we are doing, and it's working. So everybody, this is on device machine learning. So let's select another picture here. So let's say this one. No, let's say something called coffee, something related to coffee or something like that. Okay, so let's select this. Okay, as you can see here, you can see a coffee pot. So based on this 1,000 classes of labels, 1,000 labels, based on that, it says like this is a coffee pot label. And if you even go to this log here, you can see, oh my God, there are so many log. Oh, yeah. So as you can see here, I have also printed the recognition in our console. So the confidence, this model, the model is like 43% confident here that this is the image of a coffee pot, and rightfully this has a coffee pot in it. Let's say, let's select another picture. Let's select this one. So prediction palace, although this is a picture of a temple, it says palace because maybe in ImageNet data set, there are a lot of palaces with this kind of structure and there is no label for a temple. So maybe that could be a text. Let's select from camera. So let's, okay, as you can see here, this is me. Let's see if it works. Let's just say, okay. And piggy bank, penny bank. I'm not sure how this is going to, this is labeling this data, but okay, interesting. Okay, let's select another. Let's select this one. It's also, it says castle. Okay, so far good. Okay, so this is what we built so far, and what it's doing is doing image classification. Thank you so much for the comment. And so what we are doing is we are using mobile net model that we used earlier, converted it to TensorFlow Lite format, use the labels that is, it has 1000 labels. Based on this 1000 different labels, if we pass an image to this model, it will do certain prediction, and we can simply predict the prediction here in our screen, in our mobile UI, and with the image preview. So as you can see, maybe there could be some confusing part, but as you can see, it's pretty straightforward process to build an app using Flutter and use TF Lite to do on-device machine learning. And similar to this image classification, there are a lot of things you can do with Flutter and on-device machine learning. So if you go to Flutter TF Lite package, you can see there are a lot of functions that you can execute. Like in our case, we did image classification. You can also do object detection, or maybe like pix-to-pix. Pix-to-pix is a approach. If you provide an image, it will print out another image with a different style or architecture, you know, like a different style, or like art form, things like that. So generally, if you like in case of pix-to-pix, there are certain models that if you provide a sketch of an image, it will color your image and so forth, so interesting things like that. And with Deep Lab, you can do image semantic segmentation, like I briefly mentioned during my slides, and PoseNet as well. So there are a lot of things you can do with Flutter TF Lite package, as you can see. And if you see the documentation, you can properly see all these things. And one thing I like to share here is that if you are further interested in learning more about it, one of the best way you can do is that there is a repo, GitHub repo called Awesome TF Lite. And here basically using Flutter or Android, Kotlin, or Swift on iOS, there are a lot of tutorials and GitHub repo already available, which will like help you to how to properly use TF Lite models on your mobile applications. So as you can see here, there are a lot of classification, object detection. This is already available by the community. So you can simply go to this TF Lite, awesome TF Lite repo. So let me just share you here to all, okay, so to all panelists and attendees. Let me just share it here. So if you just go to here, you can see a lot of examples. Here I have also written one example which does semantic segmentation using Flutter. So in our case right now, we have used image classification, but if you want to do semantic segmentation, that is like, let's say in this case, so in this case, if you want to segment out the person in an image, so you need to do semantic segmentation. So that is also covered here. So if you go to segmentation Flutter or segmentation default, so you can go there. This is my GitHub repo. Here you can see the Dart file, and you can see how to use Deep Lab model to this semantic segmentation. Okay. So Okay, so everyone, let me share a few resources also. So this is what the awesome TF Lite repo is. Please go through that. And after that, if you want to learn more about Flutter, maybe go to flutter.dev, which I have already shared earlier. There are a lot of community and all these tutorials available here already. There is also a YouTube channel for Flutter. There is like very 2 minutes bite-sized videos that you can quickly use to learn the Flutter concepts. And there is also YouTube channel for TensorFlow Lite and TensorFlow. So maybe I'll just share it here in the chat window so that everyone can get the, so this is the YouTube channel for TensorFlow, and this is the YouTube channel for Flutter. And yeah, so let me just show you one demo for segmentation. So as you can see here, this there are two types of segmentation here. So one is real time. So in real time, what it does is that without taking any image as input, it will just open the app and it will real time segment out whatever it sees on frame basis, you know. But in this case here, you will basically select an image from camera or gallery like we did earlier, and it will do the semantic segmentation. So let me just quickly open this app that I have built, and which is also available here in GitHub, and it will give you one idea on how to do semantic segmentation. So as you can see here, this is the app. So let me just open it again. Okay, this is the app. It will do on-device image segmentation using TensorFlow Lite. So let's just select an image, and let me select my image from here. As you can see, this app is doing semantic segmentation on device without the use of any internet connectivity, you know. And this uses deep lab model, like in our earlier case we use mobile net. So this, in this case, it uses deep lab, and it is just recognizing wherever I am and doing semantic segmentation. So this is one of the application, and maybe here this one also. Yeah, as you can see, it's quickly doing this, all this semantic segmentation. So thank you everyone, and I hope this was very informative for you all. And if you have any questions, and if I fail to include anything here, let me know. I'm happy to answer all of them. Thank you.
Thank you so much, Kshitiz. If you guys have any questions, please click on the Q&A so that Kshitiz can answer some questions that you guys might have. Or you can also like raise your hand so you have a, okay, there's one Q&A. Let's look at that.
Will the recording be uploaded online?
Yes, we'll be going to upload the recording online. Okay. Are there any more questions? Before we end the session, all right, so I think there's no questions. Thank you so much, Kshitiz, for having us, for joining us tonight, and for sharing your expertise on Flutter and TensorFlow Lite. I hope everyone learned something new today. We'll make sure to upload this webinar session so that you can go through over it again. I think we'll be sharing also some of the links that Kshitiz share access on those GitHub. I think it was shared in the chat itself. So, but we'll collect it for you guys. You can send it to you so that you can actually have guidance on how you can work on this project. So thank you so much.
Thank you so much, Ralph. Thank you so much for having me. And I'm really glad and honored to be among all of you and share whatever I have learned so far. So I hope all this session was very informative, and I hope you enjoyed it. Thank you so much, everyone.
Yeah, for sure, everyone I learned. All right. Have a good night, everyone. Thank you so much for joining us.
Thank you. Good night.
Thank you. Bye.
Stay safe, everyone. Okay.
Yes.